So it's time to start with the lesson. So first of all, I want to recap the schedule. So right now this is the first lesson of the second module of the C++ course. That one clear, great. So we are entering phase number 3 of the course. So the first one was about installing an operating system, easy. The second one was even more easy, it's the C++ core language. Now we are going to dive deep into what I am calling more in C++, just to give it a name. But today we are going to see classes. That classes has been in C++ since day 0, so it's not extremely modern, but the way we will approach these topics, I will try to make it as modern as possible. So starting from this week on, so the homeworks will be a bit more difficult from previous homework in terms of I will be giving you less pointers, so they will be more like high level instructions for doing the homework, and you will be in charge of designing the API and the implementation of the classes that I will ask you to do. So just one comment. So this homework, like number 7 and number 8, will be about the final project. So this is the same as homework 5 and homework 4. So these 4 homeworks are the most important homeworks in the class because they will be used on your final project. Okay, that being said, let's start with the lesson with a really small example that I will try to motivate more or less why we should be using classes and new types in C++. But of course, this is just a small introduction. So in 10 minutes, I will try to convince you that there is a better way of writing this example. So let's start. So on this application, let's pretend that I want to model an image, like a RGB image, like a picture. And for now, let's keep it simple and short so it fits on the screen. And let's pretend that I want to have some functionality over this data. One will be like save image. So in this case, I want to save a given image to the file system, to the disk. For example, I would also like to load images from the file system. And for some given reason, I also want to check if some image is empty, right? So, by the way, we are not going to implement this functionality. So this is a high-level example. As you already know, this is so if you really want to implement this, you need to open curly braces here and blah, 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 start coding, right? But for now, let's keep it simple and just declare the prototype. We declare the function, but we don't do the implementation. So how can we start working with these images? So first we will define a new vector of bytes. So how you can do this is using unsigned integer of 8. So this is basically 8 bits that we model 1 byte, and this will be a vector. So each byte will represent 1 pixel for the given channel. We'll have a number of rows and columns. By the way, we saw one example of this on previous lesson. And then we want to populate the image. So let's say that we have the Lena image on the file system, and then we want to load the image, and then we need to pass a reference to where we want this data to be filled in. The number of rows and columns will be deducted from the files that you're reading. So when you call this, you will go here, and then you will populate this data member and also the rows and the columns. That's why these are non-const reference. So these are like input data to this particular function. And then we want to check if this image for some reason is empty. So we can check like this, or actually we can also add like rows are 0 and calls are 0, for example. So if any of these two elements are 0, or the image or this function returns empty for some reason, we can say, okay, there was an error, so I will print the user, and actually here we can return an error code and skip the program. Let's pretend that the image is not empty, so we do something here, wherever, filtering, processing, you name it, and then we want to save these results to the disk. So we will pick a new file name so we don't overwrite the previous one, and then we will pass the data to this function, and then the rows and the columns of this particular image. Okay, that was an easy example. Explained like this, looks like it's innocent, and actually there's nothing wrong with it, but there are many wrong things with this example. So one of the big issues that this example has is that it's a C-style C++ code, and it's something I am tired of seeing, and actually it makes me really mad. So I'm seeing some lags on my feedback. So if you can't see the video properly, just let me know in the comments so we can see how to solve this issue. Okay, I was saying, so this is something really common on C++. So you have std vector. So this is something that won't compile on C. So this is a C++ feature, but the rest of the code is written as if you were coding in C. And this is really wrong, because you're not using the language, you're just using the vector, right? This is one of the many reasons why this is wrong. And this is something I will be checking on your homeworks from starting today, and also on your final projects. So this is not how you will design a C++ code base. Then the second thing that is wrong is that here we have data. So these three members, data, rows, and columns, belong to each other, right? They model an image type on the real world, and they should be packed together. So, but right now they're like three variables that has no interactions with each other, and then you cannot like associate these three members, right? So there are three variables. One can be, so if you change one, the other one will not change, and so on. So you're not encapsulating the data, right? So it's spread over your program. That's problem number 2. Second problem is that every time you need to do something with the images, you, the programmer, are in charge of passing all the arguments properly. So in this case, we need to pass the data we want to populate, the rows and the columns. But maybe I am, for a destruction error, I am doing this, right? And this will compile, will run, and will not give you any error. But there is a conceptual error here. So you're misusing the columns twice. But there is nothing in this program that prevents you for doing this error. So this is unsafe unless you're a really experienced programmer, right? So this is error number 3, problem number 3. And lastly, something that is really important in C++ is type safety. So this data member here, like this guy, is just a vector of bytes. This can be anything in your program. Right now you see, no, Nacho, this is the data for the image, so it's quite clear. But actually, if you pay attention, this can be anything in your program. Maybe you have a large code base and you also have vector of bytes with some other data. And then when you, for example, save the image here, you can pass another data member that it's not an image, and then what is the expected behavior of this? Maybe it's, I don't know, there's no type safety, nothing in this program will prevent you to pass a data that does not belong to an image, right? So these are like maybe the 4 weird or most important things that this code has, like the errors, and we can fix it using modern C++, using classes. So let's go quickly, let's try to rework this. I will try to do it fast as I can. And then we will see the benefits. So first of all, we want to encapsulate this data. So we will move this out. And then we want to create a class that is called image, right? For now, let's make this public. We will see more about this. And then let's rename this. It's just a naming, right? Now we have a class image that encapsulates 3 data types. And in this case, whenever you create an image, you will have some data inside and rows and columns, and they are all stick together. So they are all in the same object, right? So now we have encapsulations. The other thing we want to do is how to, let's put this out of screen for now, is how to create this image. So I would like to, for example, create an image type from the file system. How I do this, I will just forget about this explicit word, but image, and then I want to create this from the file system, so I need a string that is the file name, and that's it. So I will not write the implementation here, it's just the prototype, right? So this is one way I would like to create images, just giving the file name and then trying to populate the image. And inside this implementation, that this is a special function that is called Constructor, I will populate these three members. So actually I can reuse the code that I did here. So this goes away. And then also, for example, I would like to create an image, an empty image. And then for this, I will use the default constructor provided by the compiler. In this case, whenever I create the image, it will be completely empty. So these are many ways of creating the images. Then, for example, every time I destroy an image, I would like to save the results to the file system, sorry. Why? Because I don't know, I just want to do it. How I do this is like I will express how I want this particular object to be destroyed with the image destructor. This is another special function, so this is another string, and then let's call it file name. There's a typo here. Good. And then whenever I destroy this image, I will when there is an error, I will save this image to the that's true. For now let's keep it like this. You cannot pass variables to the constructor. So that's one thing. So, and then this will be public to any user. And then lastly, I want to provide some functionality to this image. So for example, I want to see if this image is empty and without having to pass the correct data members to any function. So one thing I can do is I can reuse this function, but in this case, boom, I don't actually need this member, right? And I can actually mark this as const. We will see this in detail. So whenever I call this is image empty, I will know if the given image is empty without having to do anything else. And then lastly, so I also want to provide a function to save this given image, and the only thing I need right now is the file name, because all the other members are inserted inside the image class. So now we can actually rewrite our application, and it's going to look much better and it's actually more correct. So first we'll create an image. For example, let's call it image, and then we want to use the constructor of this particular new type using the like the one that accepts a file name as input argument, and then we say lena.png. That's it, right? Then we don't need to do this anymore. And then the if is image empty, we can change this like this. We can do if image is empty, and actually we can change the name of this. Let's put it empty. Then you print an error, and then inside this image empty you can do whatever you want to check rows, columns, the data, you name it, right? And then when we save the image, then we don't need to specify anymore where is the data, the rows and the columns, because everything is encapsulated within the image. So now the only thing we need to do is image and then save image and then lena new.png, and that's it. That's all. So if you compare this example with the previous example, it's easier to read, it's safer to use, and it's conceptually correct, right? Of course, you will never want to implement your own image class because there are libraries out there. but this is just a small example. Okay, with this 10 minutes example, let's try to quickly navigate through what I want you to know about C++ classes. So we will not be able to do everything in 1 hour, and I will go as far as I can, and then it's your responsibility to finish the slides and to study the topics. So you're not going to learn everything about C++ classes in 1 hour, that's for sure. Otherwise, the world will be different, and I wouldn't be as crazy as I am. The idea of this is I want to give you the pointers of the most important topics around C++ classes. So if I name bananas, then ideally you will see the one example about bananas in the slides, and then you will ideally go to CPP reference or the C++ book and look around bananas and try to understand more in detail the concepts, right? So this is just like pointers to give you a quick overview. So classes are used to encapsulate data along with methods to process them. So in our example, we encapsulated the data of the image and the rows and the columns. And the methods were like save image and asking if a given image is empty. Every class or struct defines a new type, and this is super important because you cannot mix types. So when you call the save image method from the C++ implementation, you cannot save a banana type, only images, right? That's the type safety system of C++. We saw it on previous lecture. So a type or a class is the name we will be using to talk about a defined type. I will probably be using more type than class because I like the idea better than just a class. A variable of such type is an instance of a class or an object. So when I created this, so this guy called image right here, it's basically an instance of the class image. So probably let's rename this, it's not a good name. And then Lena is an instance of the class image or just an object. And then classes will allow you to use C++ as an object-oriented programming language. So this is not the only paradigm behind C++, it's one of the many paradigms it supports. So if you want to do OOP, you can do it with C++. And for example, string, vector, all these types on the C++ system are defined as classes, right? So let's see a crash course on anatomy. So this is basically, let's highlight some stuff. So this is where you define the new type with the keyword class or struct is the same. This special function that has the same name as the class will be called constructor and destructors. This is how you create members of this class or how you destroy them. There's also something called member function that are basically all the functions defined within the class. And you can also use define operators. So when you define your own operators, you will give a high level usage to this class. We will see some examples later on. And then whatever is these variables inside the class will be called data members. And this is basically what the data that the class is encapsulating. As a quick reminder, like everything else in C++, whenever you open these curly braces, so this guy here and this guy here, you're defining a new namespace. So basically whatever is inside here will be on the namespace of the class. So this A, it's basically my new type, colon, colon, A, right? Just a reminder. Some keywords we will be using, so class definition, it's basically this guy is whatever, it's like the interface of the class without the implementation. So this is analogously to function definition and declaration. The class implementation is where you define how you will do all the functions, the constructor and the destructor. So this is where you put the C++ code. The class data member is which data you encapsulate. The member function is how you use this data within your class. The constructors are special functions that are used to create members of this class, the destructor to destroy them. There's also something called class setters that are other type of functions that will change the data members for your given class. Also, we have class getters that are members that will access these member types. For example, if you want to access the data for the images, there's also class operators, like how to work with different members of the class. And there's also static members. So class operators is one of the most fancy features, because, for example, you can have two images and then define the plus operator, and then you can write your own function on how this operator should work. So you can do image C equals to A plus B, where A and B are images, and then this plus operator is basically a function. And maybe you want to define this sum to be the sum of all over the pixels with a clamp function. I don't know, it's up to you. And there's also something called class inheritance that we will see on next lesson. So the syntax is quite easy actually. So the definition will start with the keyword class, and then the classes have 3 access modifiers: private, protected, and public. So wherever is public, it can be accessed by any other part of the program. Wherever is private cannot be accessed outside the class. And we will probably see some examples on the homework. By default, everything is private unless you specify. So if we see this example, here we say public, otherwise this will be private. And then when I mean accessing, so if, for example, I do lena.data, then I can blah blah blah, I can do something. So right now I'm outside the class scope accessing a member, and this is doable just because this member is public. If I would have like a private member, oops, not you, here like private, and then I don't know, int private. Then if I want to do lena.private, I cannot even autocomplete, and you see here an error that you're trying to access private is a private member of image. So you cannot do this like quite easily. So that's basically the idea behind private and public. So you can access any member with the dot operator, and any class will have always 2 special functions. One is called constructor, that is called upon creation of the instance, and the destructor. This will always have the same name of the class, and the destructor will have the, I don't know, this tilde here, the gnocchi, I know how to call this. So that's how you define this is a destructor. And then it's just a recommendation. Google style says use camel case for the class name. This is not strict, so the compiler doesn't care, but if you see a camel case, then it's probably a class. So what about structs? So this is for C programmers. This will be confusing. So the meaning of struct in C++ has nothing to do with the meaning of the keyword struct on the C language, right? So in C++, a struct is basically a class with all its member public. That's it. It's as easy as it is. And then the idea is that you should be using struct only as a simple data container. So it's like a class that only contains data. But if you need any type of function, then you should be using class instead. So basically, unless you have like a really easy example, you should be always using structs. The idea is that you should always initialize this type of structs with brace initialization. So whenever you define, for example, this type of struct, unless you do something weird, the compiler will generate a constructor for you, and then you can use this brace initialization syntax. What about the data? So the data of the classes can store any type. So you can have vectors, integers, member of another classes. So an image can have, I know, a filter type inside. Ideally, all this data must be private. So this is a matter of style. So there is something in object-oriented programming that is called data encapsulation, and that's why you should always mark this as private. This is how you will use it. So this is, I also do like this. You're not enforced to do it, but all the members I will always do on small letters and with the underscore at the end. This way I know I'm talking about the data member, and all the data should be set in the constructor. This means whenever I construct this an instance of the class, I need to populate all the members, all the data types, the data members inside the constructor and clean up in the destructor. So the classes will always have at least one constructor and exactly one destructor. So you cannot have like multiple destructors. There is always one destructor. So the constructor basically functions with no explicit return type, and actually this is sort of true. The name will be exactly as the class, and there can be as many constructors as you want. If there is no explicit constructor, an implicit default constructor will be generated. So if you don't define your own, the compiler will do it for you. And the same holds true for the constructor. So this is, for example, like a dummy example where you have this some class, that is the name of the type, and then you have like 3 different constructors, right? The constructor that has no arguments will be always called the default constructor. So if you don't specify any constructor while creating the object, this is the one that you will be calling. And here you have any other 2 guys, right? And for example, this sum class, so you are not passing any arguments to the constructor, then you will be using this constructor. In this case, you're using one integer, so this is the one that you will be using, and so on, right? So there are more examples there. You can play with it. So ideally, you will be using initializer list to initialize data. So whenever you use vector, you're probably using this. The name of the getter functions usually will be the same as the private member. So if you want to retrieve data from the class, then you will need to provide a function. So as a small example, let's pretend for now that this is private. And then now if I want to access the rows, the columns, and blah, 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 I cannot access because this is private, and I need to provide getters. So in this case, I can do vector of and then data, and then this way, whenever if I want to access this data member, I will do Lena and then dot data, and this is how you access the vector, and so on. So this is called getter. So getter method, right? And then a void setter. So ideally you will want to set the data in the constructor. So one other type of function you can use is setter methods, and then this will be void and set data, for example, and then you provide a uint8 and then other, and then for example this is as easy as doing this, right? And then other, and then you're basically copying the data inside the class. But this is like not a good decision. So ideally you will want to send this data here within these 2 constructors. An example here. So the declaration definition. So data members belong to the declaration. So the class methods can be defined elsewhere. So one thing you can do, for example, is let's forget about these guys. Let's remark this as public. Oops. Not you. Great. So this is the data, the class definition and implementation. Let's implement. Ooh, where is the is empty? Ah, here. Let's implement this function. How I do this? I will do image and then empty, and then this returns pool, and here is the class member class implementation. and then I will, for example, return data empty. Just an example, right? Remember, you need to access the namespace image, otherwise you will get an error. This should be marked as const. And that's basically it. Why I can access this data private member? Because inside the image namespace, I can touch my own things, right? The class name becomes part of the function name, and then there is another example here. So some key points about this is C++ allows to initialize variables in place. So this is basically what is mentioning. This is new in C++ 11. Do not initialize this in the constructor, so it's super easy. So if you want to always initialize this from 0, do it like this, otherwise you will need to do it on the constructor. And there is no need for an explicit default constructor if you have like these easy members. So if you actually try this example at your place, you will see that you can construct members of this class without providing the constructor. And then there is a small tip that is leave the members of structs and initialize. Because if you define them, then it will forbid using brace initialization, as we saw in the previous example. Then the idea behind the class is also like modular software. So the idea is you would prefer to encapsulate information that belongs together into the class. This is the example, encapsulate data, rows, and columns all together inside the class. And also you want to separate the declaration and definition. So you will have one header file to provide so this usually will be on image.hpp, and then sorry, oops, so image.hpp, and then this will be image right. So this is how you will split it. And yeah, so something that is really important about classes is something that we call const correctness. That is, if any member function should not change the data of the class, then it should be marked as const. Oops. So const after a function states that this function does not change the object. So the example here is, you know what, I will turn this the linter off because it's driving me crazy. Const, and then so clang the I love you, but for now let's disable. We need to inspect this code. Yippee, now it's cleaner. Anyway, so I was saying, so this empty function does not change the state of the class. So then it should be marked as const. This way you guarantee that whenever you create a const object, you can actually call this function. Mark all functions that should not change the state of the class as const. So unless you need to change like a setter method, any member of the class, mark the function as const. And this will guarantee you that you can pass objects by const reference and still call these functions. You will probably struggle with this with the homework. Now it sounds weird, just you will struggle most likely. So this is a typical const error. So you have a student class, and then you have one data member that is called name, and then for example, there's a typo here. You will have this getter method, and then you want to access this function, right? The thing is, there is this weird error that is always const student blah 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 as argument discards qualifiers. What is the problem with this? Is that this print function is taking a const reference to the student, and then the problem is that you as a compiler need to make sure that no one changed this student member, right? And then when you call name, there is no const here. So this const here is part of the type. So this is a const reference to a string. So this is not part of the const correctness, but here you're missing this. And even when you're not changing this name data member, the compiler cannot guarantee you that you will not change it. So it will stop the compilation and say, this name function is dangerous. It might be changing something that you declare const, because here you say this is a const reference to a student. So this is really a really typical error when using classes. Okay, so we are going to quickly discuss a topic that is called move semantics. So this was introduced on C++ 11 and was one of the big missing parts of the language. And this, you can say that this changed the story on the C++ world. I'm watching the time right now, and I think so we will most likely miss half of the slides because I'm going too slow, but I will drop after 1 hour and I will ask you to complete the slides on your place. So to talk about move semantics, we need to have an intuition on L values and R values. This is actually really easy. It sounds more complicated than it is. Basically, L value is left value and R value is right value. So it's quite easy. There are some examples here. So A is an L value because it's on the left side of the wall, and this is usually split here. So whatever is on this side is considered left value, and whatever is on this side is considered R value, right? So this this is L value, L value, L value, L value. This is going to be R value, R values, R values. So whatever is to the right is going to be an R value. So L values can be written on the left of the assignment operators, and R values are all over the expression. If you want to explicitly use an R value, then you will use the double ampersand. And this looks weird, but it's part of the syntax. So it's part of the rules of the language. And there is one utility function on the utility standard library that is move, that we will explicitly convert any L value to an R value. For example, in this case, A, so oops, this A here is a left value, but for some reason we want to convert it to an R value. Then we will use this utility, and then we will call this function over A, and then we will get an R value definition. So stdmove is used to indicate that an object T might be moved from. This actually means that allowing efficiency on transferring resources from one object to another. In particular, it will produce an X value expression that identifies its arguments T. It's exactly equivalent to a static cast on an R value reference type. So this is a definition. It's impossible to understand. So there are some examples here. So this move is part of the standard library standard utility library. The idea behind moves is that I will give you a left value and you will give me an R value to this reference. And then this is something really important. The move function does not move anything. So don't think this as taking, like, you have two objects and then when you move it, you actually move it from one place to another. What is the idea behind the move is taking ownership. So we have two objects, A and B, and then for example, B wants to take ownership of A, then you will use the move function. But the object still remains the same. So there is no moving involved. There's one example here. Let's quickly go through it. And then, so we have one print function that takes as input argument our R value, and the same function, and then we saw on the overloading examples on the function lecture, that you can use the same name of the function with different arguments, and here you use the double ampersand to say, okay, this is an Rvalue. And then if you try this example, you will actually do it. You will play around and it will help you to understand the concept. The big advice here is do not access hello after you move, because in this case, so hello it's on the left side of the equal operator, so it's a left value, and then when we call the move function, we are converting this into an Rvalue. So this print function will take ownership of this string. So you're like losing, you say, okay, this is my child, just I left it, it's already old enough, you just release ownership. So now the print function can actually own this string, and then it's undefined behavior, what will happen after you call this function. There is an example here, make sure you try that at home. And also there is another example here that I will skip, and actually there is a link here, you can click and see the performance. So if you compare like a copy from a move operator, you will see that it's actually faster. And then to summarize, and this is like 5 minutes about move semantics, it's not enough. So we should have one lecture on move semantics, so this means 1 hour. So remember, these are just pointers to point you where you should be looking information. Whenever we talk about move, you should think about ownership. So an entity owns a variable if it deletes a function scope owns a variable defining it, and then moving a variable transfers ownership. So whenever you call move on a variable, you're transferring ownership to this new member. When designing your program, you should think who should own this thing, and then you will know if you should be using move or not. If we benchmark this, the runtime is better than copy, but it's worse than passing by reference. And now we reach this point that I don't want to skip, that is operator overloading. Is any question popping up so far? Okay, so operators in C++ are basically functions. So you can actually do overloading on these operators, and this is really handy for classes. So this is a signature of any operator. So you will have the keyword operator, and then the name is basically the symbol. So for example, the plus symbol. You can take input parameters as any other function, and then you have a return type. So you can define the less operator, the greater operator, the equal operator, the assignment operator, and many more. So a list of operators are on this link, and this is one example. So we have a class human, and then this is actually a dummy example, but it's worth it. So this is the class human, and then for some reason we want to define like when a human is less than other human. And how we do this is define the operator less. Then this operator will take as input argument another human, and then this is also marked as const because it should not change the objects within this class. And then you will see, okay, if the kindness of the object you're talking it's less than the other kindness, then I am less than this other guy. So that's basically the idea. You can call this this is a Boolean operation, so you will have two humans, and then you say if human A is less than B, then you do something. Other option will be sorting. So if you want to call the std sort function, then you need to have defined this operator. And then that's all you need to do to reuse the STL sort function. So this is one really good advantage of having these templated functions and generics. So you don't need to write your own sort implementation for classes. The only thing you need to know is to say, okay, if you want to compare if this is less than the other one, that's the only operator you need to know. You can run this example and you will see that it works. Another really cool example is using the left shift bit operator. So in this case, this is the operator overloaded for all streams. And then you probably want to use, okay, cout and then just call human. So this is an instantiation of the class human. And then instead of like writing your own like, okay, human dot whatever, you can just overload the operator for all strings, and then you will basically print this message. This human is the kind whatever, and then you, for example, call the kindness that will give you the value of this data member. Again, it's better if you try it in your place to understand the functions. So this is actually really important because it's really handy to define the plus operation for point clouds, let's say. So you have 2 point clouds and then you want to add these clouds. So you have like on really behind the scenes, you will have a list of XYZ points and another list, and you just want to add all those points together. So you will want a new vector with both members from both sides. So you can write a plus operator, overload in your point cloud class, and this is going to make your code more readable. If you do this in C, what you will need to do is to create a add point cloud function, and that takes as input arguments 2 point clouds and returns a 3rd point cloud. So that's basically the idea behind all these operators. So it's to make much better code. So there are some class special functions, and this is something that people struggle a lot with because there are rules that no one wants to learn. But let's go quickly through it. One of these special functions is the copy constructor. So this is called automatically when the object is copied. For a given class, the signature of this copy constructor is like this. And there's here an example of usage. So when you create a new instance of my class and then you use the parentheses operator, then you're basically calling this copy constructor. So maybe you want to define your own implementation on how you should copy data. So in this case, it's hidden from in the slides. There's a copy assignment operator that is equivalent to the constructor that is called automatically when the object is assigned to a new value from a left value, and the signature is this one. So you overload the operator equal. And there's here an example of usage. So in this particular case, you're calling the copy you're calling the copy assignment operator. So this is another typo on the slide. So if for some reason you want to overload the copy assignment operator, you might have some reason of why you should do this. You will see some example on next lecture. There is also something called move constructor. So this is special function number 3. This will be called automatically when the object is moved. So the prototype is like this, and this is the interface as well. Again, there's the 4th one. There is something called move assignment operator. This is the interface. It's as similar as it's super similar to the copy assignment operator. The only difference is that it takes an Rvalue as reference. And there is one example here. And there are all those 4 operators defined here. So this is an example that you should try. Try to type it by your own, and then you will see like when you're calling each one. But basically, if you, for example, focus on the usage, so let's take this out. So if you focus on how you will use this particular class, it's basically using any other type. So you create a member, then you assign it, but behind the scenes there's a lot of stuff going on. And then this is something that you should start paying attention when writing C++ program. So in C, this is usually trivial because you're basically assigning built-in types. But in your case, you will be defining your own types, and all these single operations, like an innocent equal, can be a whole function implementation. So just keep in mind that there is something always behind the scenes in C++. And then, so wow, many functions, much scary. Do I need to define all of them? So the constructor and operators will be generated automatically. So constructors, the default constructor, the default destructor, and these 4 special functions makes 6 functions, so it's a lot of code to write, but this will be generated automatically by the compiler under some conditions. So this is a rule of all of anything. So if none of them are defined, the compiler will do it for you. So this is, for example, what you should be using for homework number 4. So don't define any of these 6 special functions. But if you, for some reason, define any of these 6 special functions, then none are auto-generated. So let's pretend that for some reason you say, okay, I will define the destructor. Okay, then all these 5 other functions are not defined by the compiler anymore. But if you don't define any of them, the compiler will do it for you. So the idea is that's the rule of all or nothing. So try to define none of the special functions, because usually the compiler will give you a better implementation unless you really need to do it. If you must define one of them, then you need to define all of them. And then if you want to, for example, just define the destructor, and then you don't want to write the implementation for the other 5 special functions, then you just call this equal default, and then this will tell the compiler, okay, compiler, just use the one you were expecting to use. I trust you. So this is how you should use it. And then lastly, you can also delete functions. We will see how to use this when we study the singleton pattern next lesson, that will be also used on your homework number 7. But basically any function can be marked as deleted, and then when you try to call this function, then the compiler will say, okay, this function for some given reason is not implemented and it's deleted, so you are not allowed to call this function. And then there's this singleton pattern example, and we will see, like, I will copy the slides when we see the singleton pattern. And then almost lastly, we will see static variable methods. So let me check one thing. We're going with time. So this is something that is usually confusing for a lot of people. Again, I feel like this is a lot of information for 1 hour, but ideally this will be the glossary for searching other terms or to Googling stuff or watching tutorials on CPP reference. So yeah, okay. So remember that whenever you see or think as the word static in C++, this means something that is somehow related to compile time processes. So if it's marked as static, it's something that should happen at compile time, right? And wherever it's dynamic, it's something that will happen at runtime. So you can have static variable on your class. So this means something that will happen. So will be created at compile time and not at runtime, and will be only one for class. So we saw an example of static variables on lecture 3, I guess, but this is basically the same. The value will be the same across all instances, and actually before C++ 11 you need to give this value on the CPP function file. But now on C++ 17, you can create a header file and say static variable and give the value there. Then you also have static member functions. This is something that might be useful when you're designing your own types. Do not need to access through an object of the class. So because this is static, then it's created, this function will be created at compile time. So you don't actually need to create an object of this particular type to call this function. That's the idea. And can also access private members, but need an object. So the syntax is you use the class name namespace, and then you use double colon, and then you call the static method. Example here is static variables. So on this case, we have this integer variable that is static. So we want to keep like how many objects are created. So whenever, and here we're defining a custom constructor and a destructor, and whenever we create an object or destruct, we will increment or decrement this function. So you can use it like without doing anything more. Just make sure you try this example. So this particular thing here, so this is basically giving a value at compile time to this static variable. This is not needed in C++ 17. So on C++ 17, you will put here on the declaration, you will put here equals to 0, right? And then you have count objects, and every time you create an object or you destroy it, then you will see how many times it will be this count increments. So try it at your place. This is, for example, another example on static member functions. So for example, this distance function. So let's say you have a class point, and then you want to compute the distance between 2 points. So it's actually weird. Let me see. Yeah, it's actually weird if you call this function, because you're saying if you are calling a dist member function, you're actually computing the distance between P1 and P2, but the syntax is weird. Then it's not really clear what's going on. So you will actually want to call a distance function on points. So that's why now it belongs to the class, and it's not like a floating function somewhere else. And then you pass as arguments 2 points. This distance function that is marked as static does not need to instantiate an object of the class. So you can call this without creating any object. And then it will take 2 points as reference, and then it will compute the distance and then return a floating point value. So if you find yourself on this kind of situation, so static member functions are ideal for this case. And lastly, there's this using keyword that is replacing the type def from C. So ideally, you should not be using type defs for some reasons, but with this you can create type alias. So we saw some examples on the homeworks, but basically the syntax is using and then you type, and then you create you mark the old type. For example, using vector float equals to std vector angular brackets float, right? So this using word is quite versatile, so you can use it for namespaces, for types. And when used outside of functions, declare a new type alias. And when you use inside the function, we'll create a type alias, but within the scope of the function. So this is something that you should start using from now on to make your code more readable. So this is basically has no impact on the runtime, and actually improves the code readability. So in this case, we have an image that takes as template input arguments to types. And for example, I want to use an image float that will be this class image with the type float and then with a given size, right? And this is some type aliasing. There are some examples here. The idea is that you should be using this to reduce verbosity of your classes in C++. And then lastly, super quickly, enumeration classes are a new feature in C++. Enum types are from C, but not classes. So this is what is also called scope enums. You can have an enumerated type, but scope within a class namespace. So the example here is like, so you have this enum class channel, and then you have std out and std error. There are many reasons why this is better than just using plain enums. For now, just take this as granted, use enumeration, scope enumeration instead of plain enumeration. And then whenever you want to, for example, you want to switch, and then according to the channel, you print, for example, a message to the cout, the standard error or whatever, and then you can do case and then channel std out, that is the first enumeration, and then std error. And then the difference here is this little guy. So you have this enumerated type is under the namespace of the class channel. So std out and std error is basically 0, 1 in this example. So this can be anything. So you can ideally put case 1 here, but when using scope enumerations, then the compiler will guarantee you that you actually don't access don't use these mixed numbers. So it has a more high level understanding of the enumeration. You can also add explicit values. Okay, 1 hour. So that was a lot of information. Most likely, the summary is that we saw the basic anatomy of C++ classes, how to work with const correctness and move semantics. Again, it's impossible that you actually learn this in 1 hour. So this is basically a pointer. So after this lecture, so you probably don't even need to rewatch the lecture, but you should know what you should be looking for. If you just type in Google C++ classes, there will be a lot of information. So ideally, I am trying to give you what is most important about all this information. So if you want to dive deep on classes, then go to CPP reference. There's a lot of examples and they're actually self-contained, and it's actually really easy to understand from those examples. Also, make sure you remember there is something called operator overloading. So don't write add image functions. You can use the plus operator and define the function there. And then also remember the class special functions. There are 6: constructor, destructor, copy assignment operator, move assignment operator, copy constructor, and move constructor. If you define one of these 6 guys, then you need to define all of them. You can use the default flag to the compiler to tell, okay, this you will define yourself. And if you find yourself relying on methods that should not be called from objects itself, you can add static variables and methods to your classes. Right? Videos for this week. There is a 10 minutes introduction to C++ classes. So I actually like this channel on C++. The only thing I don't like is that this guy uses the Microsoft Visual Studio IDE, and then half of the things he do is black magic that no one understands besides Microsoft. But the concepts are explained clearly, and they're 10 minutes videos, so not 1 hour. So you can actually go and check it out. Then there is a small interaction in unit testing. So this is something that was planned for this week. So you should look at least this 10 minutes interaction. And if I have time between this week and the following, I will be giving you a tutorial on unit testing. That is something that I will ask you to do starting from from homework 7, 8, 9, and then the final project. So it's something you should learn how to use. It's not super complicated. And then there are a lot of references that I've used across these slides. So there are 2 slides with references. So make sure you click on all of these links and at least read the introduction. Thank you for your attention.